Okay, so in this video, we're going to look at what's called the ruler postulate. All right. So what you should do is pause the video right now and copy all this stuff down into your notebook. And once you have all this stuff copied into your notebook, unpause the video and I will continue explaining. So pause the video, copy this into your notebook, and then come back in just a second and I'll be here. Okay, so we're talking about now we're getting into lines and measuring segments. One of the things that comes into play when we're talking about segments of lines is what's called the ruler postulate. Remember, in the beginning of class, we said that a postulate is just an accepted statement of fact. So this is one of those statements of fact that we can come up with that's going to help us figure out the distance between points on a number line. Notice that the ruler postulate up here states that the points on a line can be arranged with real numbers so that the distance between any 2 points is the absolute value of the difference of the corresponding numbers. All right, now that's a lot of words and a lot of things being said there. The fancy way of saying what's over here in this example. Look, if we look here at this example, I've got 2 points on a line, A and B. If I want to find the distance between those 2 points or the length of that segment, the ruler postulate says that if I take the absolute value of the difference between them, A minus B, that will give me the length. Okay? Again, that's sort of out there. You have to kind of think about it. It's not real concrete, so I put a little example with some numbers here. If you look down here, we've got a number line 1, 2, 3, 4, 5. Points C and D are at 1 and 5 respectively. If I wanted to find the length of segment CD on this number line, all I have to do is take the absolute value of the difference between the numbers on the number line. So the length of this segment CD is equal to the absolute value, those up and down lines mean absolute value, of C is at 1, so 1 goes there. D is at 5, so 5 goes there. Remember that 1 minus 5 is equal to negative 4. And then the absolute value, remember, it just cuts off the negative and makes every number positive. If it goes in positive, it comes out positive. If it goes in negative, it comes out positive. So in this case, negative 4 becomes positive 4, and we know that the length of that segment, CD, is equal to 4. Okay? That's all the ruler postulate is saying. It's just saying, take the numbers, subtract them, make the number positive. That's the length of your segment. All right? So let's look at an example here. We've got this big old number line here. It's starting at negative 8, goes all the way up to 4, and we've got several points on this line. We've got A, B, C, D, and E. All right. Now, in the first number here, it says to find A, B, and BC. They want us to find the lengths of these segments. Notice they're segments, so we should probably have the little segment bar above it if we're going to be technical about it. And then they want us to know, then they're asking, are A, B, and BC congruent? Remember in the previous videos I said that congruent is just a fancy way of saying that numbers are equal. All right? Actually, it's right up here. Congruent segments in this little section, 2 segments with the same length. So it's just a fancy geometry way of saying that numbers are equal. All right? So finding the lengths of AB, if I want to find the length of AB, we know that that's going to be the absolute value of the number at A, which is negative 8, minus the number at B, which is negative 5. And if we crunch that out, negative 8, remember, minus a minus means plus. So remember the keep, change. Negative 8 plus 5 is negative 3. And then the absolute value of that is 3. So the length of that segment AB is 3 on this number line. To find the length of BC, we do the same thing. Segment BC is equal to the absolute value. The first letter is B, so here we are at negative 5. We're going to subtract the length at C, which is negative 2. So then negative 5 minus a minus again becomes plus. So negative 5 plus 2 is equal to negative 3. So the absolute value of negative 3 is 3. So obviously these two are the same. So we can say, are AB and BC congruent? We can say, since segment AB is equal to segment BC, then segment AB is congruent to BC. Notice this little symbol right here. This is a symbol you're going to see a lot in geometry. It means congruent. It means that they are both equal and similar in shape. Okay? So that's the first example. Take a second and try this second example on your own. Pause the video, and when I come back, I'll explain how to do it. Okay, so we're looking at CD and DE. So to find the length of segment CD, we just want to go up to C. That's at -2, so that's the absolute value of -2. We're going to subtract from it the value at D, which is 0. So in this case, -2 minus 0 is going to be -2 back again. And the absolute value of -2 is 2. In this case, then, we want to find DE. So we'll do the same thing. Segment DE. That's equal to the absolute value of the value at D, which is 0, minus the value of E, which is at 2. So 0 minus 2 is equal to -2, and the absolute value of -2 as 2. So notice they're both the same again. So since segment CD is equal to segment DE, then segment I'm looking at the wrong problem. Segment CD is congruent to segment DE. Alright, if you have any questions, write them down and bring them to me in class.